Bismillahirrahmanirrahim. Sampling part 3. In this session, we'll continue from where we left in our last session, and that was about sampling, and within the sampling, the first type of sampling, that was probability sampling. We discussed a number of samplings within probability sampling. One of them was left, that was multi-phase sample. We'll complete that one, and then we'll move on to the other type of sampling in research, and that is non-probability samples. And within non-probability samples, we'll discuss convenience sampling, quota sampling, proportion rate sample, purposive sampling, dimensional sampling, snowball sampling, volunteer sampling, and theoretical sampling. Then we'll move on to discuss planning a sampling strategy, and then conclude usually the session on sampling, summing up all we have done so far and what insights we can get from these sessions while making an appropriate or suitable sampling for our research plan. So let's begin with the first point, that is multi-phase sampling, that is part of probability sampling we discussed in our last session. In stage sampling, that was the last we discussed, there is a single unifying purpose throughout the sampling. In the previous example, the purpose was to reach a particular group of students from a particular region. Yeah? In a multi-phase sample, the purposes change at each phase. For example, at phase 1, the selection of the sample might be based on the criterion of geography. For example, students living in a particular region. Phase 2 might be based on an economic criterion. For example, schools whose budgets are administered in markedly different ways. And phase 3 might be based on a political criterion. For example, schools whose students are drawn from areas with a tradition of sport for a particular political party, and so on. What is evident from this is that the sample population will change at each phase of the research. That's why it is called multi-phase sampling. In a multi-phase sampling, the key point is change the sampling strategy at each phase of the research, and different samples for different stages of the research. For example, junior employees at stage 1, middle management at stage 2, senior management at stage 3, determined by the purpose or the purposes of the research. Okay, that was about multi-phase sample, which states that at each phase the research and different samples of different stages for the research. And that was the last category of probabilistic sampling. Now move on to non-probability samples. The selectivity which is built into a non-probability sample derives from researcher targeting a particular group in the full knowledge that it does not represent the wider population. It simply represents itself. This is frequently the case in small-scale research. For example, as with 1 or 2 schools, 2 or 3 groups of students, or a particular group of teachers, where no attempt to generalize is desired. This is frequently the case for some ethnographic type of research, or action research, or case study research, and we'll discuss these in our coming sessions. Small-scale research often uses non-probability samples because despite the disadvantages that arise from their non-representativeness, they are far less complicated to set up, are considerably less expensive, and can prove perfectly adequate where researchers do not intend to generalize their findings beyond the sample in question, or where they are simply piloting a questionnaire as a prelude to the main study. So that is the primary function or the area where non-probability samples would be appropriate. So non-probability sample, the key point is that members of the wider population are deliberately excluded. Purpose is not to generalize or reach and comment on the larger or wider population. The aim is for the sample to represent itself rather than to wider generalizability. So these 2 pictures on the slide would show that purpose is the sample itself, the person itself, the case itself, and it is beyond generalizable to the wider population. Just as there are several types of probability sample, so there are several types of non-probability sample, such as convenience sampling, quota sampling, dimensional sampling, purposive sampling, and snowball sampling. Each type of sample seeks only to represent itself or instances of itself in a similar population, rather than attempting to represent the whole undifferentiated population as we discussed in probability samples. So let's take these non-probability samples one by one. The first one is convenience sampling. So convenience sampling, or as it is sometimes called, accidental or opportunity sampling, involves choosing the nearest individuals to serve as respondents and continuing that process until the required sample size has been obtained, or those who happen to be available and accessible at the time are included in the sample. So captive audiences such as students or student teachers often serve as respondents based on convenience sampling. Researchers simply choose the sample from those to whom they have an easy access. As it does not represent any group apart from itself, it does not seek to generalize about the wider population. For a convenient sample, that is an irrelevance. The researcher, of course, must take pains to report this point, that the parameters of generalizability in this type of sample are negligible. A convenient sample may be the sampling strategy selected for a case study or a series of case studies. Convenience sampling. Look at these photographs. Okay, they are giving you an idea what type of convenient sampling would be. It would be the same group you teach or you study with. Easy approach, easily accessible. So that's why it is also called an opportunity sample, after those to whom there is an easy access. Another kind of non-probability sample is called quota sampling. Quota sampling has been described as the non-probability equivalent of stratified sampling. Like a stratified sample, a quota sample strives to represent significant characteristics of the wider population, and unlike stratified sampling, it sets out to represent these in the proportions in which they can be found in the wider population. Let me give you an example to illustrate this quota sampling. Suppose that the wider population were composed of 55% females and 45% males. Then the sample would have to contain 55% females and 45% males. If the population of a school contained 80% of students up to and including the age of 16 and 20% of students aged 17 and over, the sample would have to contain 80% of students up to the age of 16 and 20% of students aged 17 and above. So a quota sample then seeks to give proportional weighting to selected factors which reflect their weighting in which they can be found in the wider population. The researcher wishing to devise a quota sample can proceed in 3 stages. And what are they? Number 1, identify those characteristics or factors which appear in the wider population which must also appear in the sample. That is, divide the wider population into homogeneous and, if possible, discrete groups, for example, males and females, Asian, Chinese, and African Caribbean. Number 2, identify the proportion in which the selected characteristics appear in the wider population, expressed as percentage. And number 3, ensure that the percentage proportions of the characteristics selected from the wider population appear in the sample. So proportionate or a quota sample would be, yes, I've just mentioned the stages. Yeah. Proportionate quota sample. Stage 3 would be ensure that the same percentages of characteristics appear in the sample. And stage 4, calculate the total percentage and divide it by the highest common factor of the cells in that column. And stage number 5 would be add together the totals for the column to find out the total. Ensuring correct proportions in the sample may be difficult to achieve if the proportions in the wider community are unknown or if access to the sample is difficult. Sometimes a pilot survey might be necessary in order to establish those proportions. And even then, sampling error or a poor response rate might render the pilot data problematical. So it is straightforward to determine the minimum number required in a quota sample. Let's say that the total number of students in a school is 1700, made up in this way. So say performing arts students, there are 300 students. Natural sciences, there are 300 students. Humanities, there are 600 students. And business and social sciences, there are 500 students. So what would be their proportion? That would be 300 students, and 3 again, and 6, and 5, and total would be the minimum sample required would be 17. That's what you do. You add 3 plus 6 and 5. 3 for the 300, 6 for 600, and 5 for 500. That is the proportion. In quota sampling, the proportions being 3, 3, 6, 5, a minimum of 17 students might be required for the sample. Of course, this would be a minimum only, and it might be desirable to go higher than this. The price of having too many characteristics in quota sampling is that the minimum number in the sample very rapidly could become very large. Hence, in quota sampling, it is advisable to keep the numbers of strata or characteristics to a minimum. The larger the number of strata or diversity, the larger the number in the sample will become, usually at a geometric rather than an arithmetic rate of progression. That was about quota sampling and how to take the proportionate of the quota. Now another type of non-probability sample is a purposive sampling. In purposive sampling, often, but by no means exclusively, it is a feature of a qualitative research. Researchers handpick the cases to be included in the sample on the basis of their judgment of their typicality or possession of the particular characteristics being sought. In this way, they build up a sample that is satisfactory to their specific needs. As its name suggests, purposive, the sample has been chosen for a specific purpose. For example, a group of principals and senior managers of secondary school is chosen as the research is studying the incidence of stress among senior managers. A group of disaffected students has been chosen because they might indicate most distinctly the factors which contribute to students' disaffection. In many cases, purposive sampling is used in order to access knowledgeable people, that is, those who have in-depth knowledge about particular issues, maybe by virtue of their professional role, power, access to networks, expertise, or experience. If you want to know more about this, you can read Ball 1990. There is little benefit in seeking a random sample when most of the random sample may be largely ignorant of particular issues and unable to comment on matters of interest to the researcher, in which case a purposive sample is vital. Though they may not be representative and their comments may not be generalizable, this is not the primary concern in such sampling. Rather, the concern is to acquire in-depth information from those who are in a position to give it. Another variant of purposive sampling is the boosting or the boosted sample. According to Gorard 2003, comments on the need to use a boosted sample in order to include those who may otherwise be excluded from or underrepresented in a sample because there are so few of them. For example, one might have a very small number of special needs teacher or pupils in a primary school or nursery, or one might have a very small number of children from certain ethnic minorities in a school, such that they may not feature in a sample. In this case, the researcher will deliberately seek to include a sufficient number of them to ensure appropriate statistical analysis or representation in the sample, adjusting any results from them through weighting to ensure that they are not overrepresented in the final results. So this is an endeavor perhaps to reach and meet the demands of social inclusion. So you can look at these diagrams which are chosen for specific purposes. You have a specific target. If you have in your research, then you can use a purposive sampling. Next type of sampling, that is non-probability sample, is a dimensional sampling. So one way of reducing the problem of sample size in quota sampling is to opt for dimensional sampling. Dimensional sampling is a further refinement of quota sampling. It involves identifying various factors of interest in a population and obtaining at least one respondent of every combination of those factors. Thus, in a study of race relations, for example, researchers may wish to distinguish first, second, and third generation immigrants. Their sampling plan might take the form of a multi-dimensional table with ethnic group, across the top and generation down the side. A second example might be of a researcher who may be interested in studying disaffected students, girls and secondary age students, and who may find a single disaffected secondary female student that is a respondent who is the bearer of all of the sought characteristics. That was about the dimensional sampling. Another kind of non-probability sampling is called snowball sampling. In snowball sampling, researchers identify a small number of individuals who have the characteristics in which they are interested. These people are then used as informants to identify or put the researchers in touch with others who qualify for inclusion, and these in turn identify yet others, hence the term snowball sampling is used. This method is useful for sampling a population where access is difficult, maybe because it is a sensitive topic. For example, teenage solvent abusers, or where communication networks are undeveloped. For example, where a researcher wishes to interview stand-in supply teachers, teachers who are brought in on an ad hoc basis to cover for absent regular members of a school's teaching staff, but finds it difficult to acquire a list of these stand-in teachers. Or where an outside researcher has difficulty in gaining access to schools, going through informal networks of friends, acquaintance, and their friends and acquaintance, and so on, rather than through formal channels. The task for the researcher is to establish who are the critical or key informants with whom initial contact must be made. So snowball sampling would be something like this, that one sample leads on to more of the sample kind of sample. Okay? The snowball gathers. You have contact with one person, he gives you reference to another person, and from there you get other, and in this way it rolls on and sample increases. So that's why it is called snowball sampling. Like a snowball, it increases gradually. Next is another type of non-probability sampling that is called volunteer sampling. So in cases where access is difficult, the researcher may have to rely on volunteers. For example, personal friends, or friends of friends, or participants who reply to a newspaper. Participants who reply to a newspaper advertisement are those who happen to be interested from a particular school or those attending courses. Sometimes this is inevitable according to Morrison 2006, as it is the only kind of sampling that is possible, and it may be better to have this kind of sampling than no research at all. In these cases, one has to be very cautious in making any claims for generalizability or representativeness, as volunteers may have a range of different motives for volunteering. For example, wanting to help a friend, interest in the research, wanting to benefit society, an opportunity for revenge on a particular school or head teacher of the school. So volunteers may be well-intentioned, but they do not necessarily represent the wider population, and this would have to be made clear in the research plan. That was about volunteer sampling. Now we move on to another type of non-probability sample, and that is called theoretical sampling. This is a feature of grounded theory. In grounded theory, the sample size is relatively immaterial, as one works with the data that one has. Indeed, grounded theory would argue that the sample size could be infinitely large, or as a fallback position, large enough to saturate the categories and issues, such that new data will not cause the theory that has been generated to be modified. Theoretical sampling requires the researcher to have sufficient data to be able to ground the theory in the research context, however defined, that is to create a theoretical explanation of what is happening in the situation without having any data that do not fit the theory. Since the researcher will not know in advance how much or what range of data will be required, it is difficult to the point of either impossibility, exhaustion, or time limitations to know in advance the sample size required in a theoretical sampling. The researcher proceeds in gathering more and more data until the theory remains unchanged, or until the boundaries of the context of the study have been reached, until no modifications to the grounded theory are made in light of the constant comparison method. So that was all about non-probability sampling. Now the question arises how to plan a sampling strategy. So there are many steps in planning the sampling strategy, and some of those I have mentioned here. First of all, as a researcher, you need to decide whether you need a sample or whether it is possible to have the whole population. And if there is a possibility that you can use a sample, then go for it. But if the population is not wide or large, you can use the whole population. So that will be your decision, whether to take the whole population or a sample from the population according to the nature of your research and research question. Second, identify the population, its important features and its size. What are the key characteristics or features of the population. And you have to select your sample according to the characteristics of the population. Identify, number 3, identify the kind of sampling strategy you require. Which variant of probability and non-probability sample you require. So you have to decide whether you need a probability sample or a non-probability sample. And keep in your mind that probability sample are samples we discussed in our previous session, that is mostly for quantitative or positivistic approaches, and non-probability samples are predominantly used in qualitative type of research. And what's the difference between the two? The purpose of positivistic approach is to generalize for the population, whereas in a qualitative type the purpose is not to generalize the results or the findings. Purpose is to study them in depth. Number 4, ensure that access to the sample is guaranteed. You have to make sure that you have decided about the population sample, you have decided it would be probability sample or non-probability sample. Then the question arises whether you will be able to access them, whether you will be able to reach them or not. So make sure that you would have an access to the sample and that is guaranteed that you will reach them, and there won't be a problem, any problem. We discussed a number of issues in the previous session. So if it is not guaranteed, the access, so be prepared to modify the sampling strategy. Use some other strategy so that you can get the appropriate sample. If it is a probability sampling, then you have to identify the confidence level and confidence intervals that you require. Well, in our previous lecture, we discussed a number of probability samples, and with reference to that, we discuss different levels of confidence levels and also the confidence intervals. So what's the difference between them? Confidence level in statistical terms we discuss with reference to 3 different ways, or at 3 different levels, and that was the 90% sure, or 95% surety, or 99% surety of the confidence. So you want to see that your results are 90% of the time correct, a higher confidence would be 95%, and a bit more higher would be the 99% of the cases are correct. And confidence level, we said that could be at 2, again at 3 levels. That would be plus, minus, 3. And with reference to survey voting polls, we discussed that usually in newspaper polls or the survey polls, they give the interval of plus minus 3. And that plus minus 3 shows what? That say if it is said that 40% vote would be cast in favor of one particular party. What does that mean statistically? It means that it could be as much higher as 43, or it could be as low as 37. Means if it is positive, then it will be 4 plus 3 is 43, and if it is in a negative, it would be 40 minus 3 would be 37. So that would be the range between 37 and 43. It can go anyway. So that was about the confidence level and the confidence interval. Number 5, for non-probability sampling, identify the people whom you require in the sample. So non-probability sampling, and in most of the cases that is not for generalizable. So you need to identify the people whom you require in the sample, and that would be the results would be applicable, of course, to that particular group, but the choice of the group or include the people in the group should be the typical one. And by typical I mean it should have the characteristics of the features of the population it represents to some extent. Next, calculate the numbers required in the sample, allowing for non-response, incomplete or spoiled responses, attrition and sample mortality, that is built-in redundancy. You know, when you distribute, especially the questionnaire, in some cases you don't get any response. Some questionnaire come but they are incomplete, or in some cases they are just spoiled by the respondents, or some people forget to return, and in that case there would be a sample mortality. So there should be some sample should be greater, and these issues should be kept in mind while doing any kind of sampling. Next, you decide how to gain and manage access and contact. How will you reach to the sample and the people? Will it be through the advertisement, or you write them letters, or you will telephone them, or email them, or you personally visit them, or you will contact them personally, or through your friends? So be prepared to weight the data once it is collected. And to weigh the data means how to adjust according to the number of people in it. Are they representative within the group? Well, if it is a stratified, that you don't have a homogeneous group, but within the group there are the subgroups. So what weightage you will give them? Okay, those were some of the strategies you need while planning a sampling. Now we have almost reached towards the end of this session, towards the conclusions. In the conclusion, I would say the message or the purpose of this lecture or these sessions on sampling we discussed is the same as for many other lectures I have given, and the gist of all of them was that every element of the research should not be arbitrary. It should be planned and it should be deliberate, and that, as before, the criterion of planning must be fitness for purpose. So there is no one size which fits all types of research. So your purpose of the research would lead or inform the criterion of planning, and planning should be at all stages. The selection of a sampling strategy must be governed by the criterion of suitability. The choice of which strategy to adopt must be mindful of the purposes of the research, the time scales and constraints on the research, the methods of data collection, and the methodology of the research. The sampling chosen must be appropriate for all of these factors if validity is to be served. To the question, how large should my sample be, we started with. The answer is complicated. And this session has suggested that it all depends on a number of factors. And what are they? Number one, it's the population size. So the question, how large should my sample be? The answer is complicated, and it all depends on these 10 factors. Number one, the population size. How big, wide is your population? Number two, confidence level and confidence interval required. Number three, accuracy required. The smallest sampling error sought, not the highest sampling error. The smaller sampling error would be plus minus 1. And if it is plus minus 5, it would be the higher. Number of strata required. If there are too many subgroups, strata, within the sample, then you need a wider or a bigger or a larger sample. Number 5, number of variables included in the study. The more variables, the larger the data. And in the coming sessions, we'll explain, we'll discuss what are the variables. There are different types of variables. Variable basically is from vary, anything which changes, like age changes, time changes, weight changes. So anything which changes and it has an effect on your hypothesis, your research. So what are the variables? There are two types of variables, that is independent variables or dependent variables or controlled variables. Number 6, variability of the factor under study quantitative research. So variability of the factor under study quantitative research, the kind of sample. There are different kinds of sample within probability and non-probability sampling we discussed. So what type of sampling you will be using also gives an idea about the type of how big your sample be. If it would be a probability sample, gradually it would have a large or a bigger sample as compared to a non-probability sample. Then the representativeness of the sample. How your sample is representative of the population. So if you want it to more representative and accurate, you need a large number in your sample. And allowances to be made for attrition and non-response. So if you have a fewer number and some of them get missed or they leave research, there would be a problem. So you need to make sure that there would definitely be some mortality, there would be some losses of forgetfulness, so it should be accommodated in the plan. And there's need to keep proportionality in a proportionate sample. It's not just the people you come across and you include them in the sample. It should be well planned, and if there are different types of people or strata, so what is their representation, or what is their proportionate number? Do they proportionate in the sample or not? Well, that was about the sampling. We started with the purpose of sampling. Its types, basically two, probability and non-probability, and within each there are different strategies of sampling. With examples illustrated, and I think now that you will be in a position to adopt the right strategy for sampling and take your data from the representative sample. Our first lecture was about the size of the sample, and there were certain points raised about how big the size could be, and then what could be the problems, like standard errors in any kind of sample. And why there would be an error? Because whenever you choose people, you select them and you choose them from a wider population, and there is a chance that the people included in the sample may not have the features or characteristics found, all the characteristics found in the population. So there is a chance of an error, but that error can be minimized or diminished by using statistical procedures. And statistical procedures we have discussed with reference to the sample size in the beginning. Then we discussed different ways to make the sample representative, and the representative is the most important aspect of any sampling, and on the basis of a representative sample you can make a claim. You can present it as an evidence, and your results would be more reliable and valid if the data is representative. If it is not representative, the results won't be valid. So purpose is not just to collect data or make a sample, The purpose is to make it appropriate and representative. Why to do that? The purpose is to make claims. And if it would be representative, the results and the claims would be authentic. Well, then we discuss a number of probability and non-probability samples with examples, illustrations, and at the end we discuss some of the strategies which any researcher need to adapt while planning research. I'll end it with a point emphasizing that the most important element in research is the representative sample. And most of the students are questioned during their viva, and if their results are published, if they are not representative, they are criticized. So be familiar with all types of sampling, and especially to choose the appropriate one for your own research. That is the end of the session. Up till then, goodbye, and thank you very much for listening.